Hello, welcome to a summary presentation of Experiment 7 in the first wave of DIGITbrain Project. This experiment was dedicated to data-driven modeling of the powder bed fusion technology. Here are the experiment partners. The end user of the experiment was Croom Precision Medical from Ireland. As an end user, Croom was manufacturing technology and data provider of the experiment. The independent software vendor of the experiment was Multimatch from France. Multimatch implemented the solution from the data provided and integrated the solution into project platforms. SMAC Digital Innovation Hub, hosted by Tampere University in Finland, supported the experiment implementation. Our technology focus was selective laser melting technology and the Renishaw machine available from the end user side to manufacture medical devices such as medical implants. While using this manufacturing technology, there is a high risk for failure during the manufacturing phase, which can ultimately cause defects in the parts or complete build failure. These failures can be extremely costly and cause material and energy wastage. Therefore, there is a need for improved and automated process monitoring in order to reduce the cost, increase reliability and traceability, and to enable more sustainable and greener production. This challenge was derived from the end user as well as the gap in the market. Toward this end, the objective was developing a solution or software tool, including machine learning models, to detect anomalies for process intervention, quality control, and traceability purposes. In other words, the solution is intended to be a tool for automated monitoring and analysis of the melt pool and image data for defect detection. The solution should detect defects within the process and provide an alert using an alert system. It was also expected that the solution should perform a statistical analysis on the sensor data to evaluate the entire build. As a result of our collaboration, after the requirement extraction and ideation phase, a design of experiment is carried out to gather required data. Data were then labeled according to the expert knowledge, the solution architecture is designed, and the solution development took place. The solution were fully implemented and integrated to the project's platform and finally evaluated by the end user as well as the technical core partners. Here is a quick overview of the solution. To access the solution, user can log into platform and work with the developed UI. Let's see a short demo of the solution. User can select the intended algorithm, transfer and upload the required data from the user interface and run the solution. Once the results are ready, in case of anomaly detection, an alert window will pop up which summarizes the bad quality elements and layers. For better usability, the color-coded elements are also visualized, in which red color represents defect in the elements and green represents good quality, as it is shown here. A quality report is then generated and user can define the threshold. Additionally, the solution also provides statistical analysis on the input data. As a result, end user is able to automatically handle and analyze large data sets to improve quality, reduce cost, material waste, and energy consumption. The system will be used to inspection production builds of more than 50 parts per month. Based on this, it will accelerate the process monitoring analysis and make it now possible to do automated statistical analysis, which was previously not available commercially for these data sets. The solution ultimately leads to reduction in time to market for new products. Software provider gains significant technology-related knowledge and ability to enter a new market, as well as broadening their market influence and business growth. To exploit the solution, our plan is to create a partnership among the experiment partners and to further develop the detailed features of the solution, such as extension of a trained machine learning models with different datasets, extension of alarm types, and data encryption. Thank you for your attention on behalf of Experiment 7 partners.